Hello, welcome you all on Kota Scholar. In this lecture, we are going to study about trigonometric equation. Before that, we are done with what trigonometric ratio is. And trigonometric ratio will become the prerequisite for this lecture. That means you should be good with your trigonometric identities as well as how we used to convert sum or product, sum or difference of two trigonometric function into their product. So before we actually start with the definition part or how to solve a trigonometric equation, let's discuss this quadrants. Remember how do we form angles? Angles is the result of amount of rotation between two co-initial rays. So if we are on the positive x-axis, then we'll get angles like 0, 2 pi, 4 pi, plus or minus 2 pi, plus or minus 4 pi, plus or minus 6 pi, so on and so forth. Where positive sign indicate that we measure the angle in anti-clockwise sense, wherever negative signs, it indicates that we measure the angle in clockwise direction. See, if we are on a negative x-axis, then how we reach up till there? By revolving an angle pi, if anti-clockwise is measured. But if we are measuring this in clockwise sense, then will be at the angle will be negative pi. So if we keep adding 2 pi in that result, then each and every time will be on negative x-axis. That means these are the angle which ensure that where you are, it locate your position. Similarly, if I add a pi by 2, if I add a pi by 2 in each initial angles, I will be at positive y-axis. So angles like pi by 2, 2 pi plus pi by 2, 4 pi plus pi by 2, so on and so forth will ensure that you are right there on positive y-axis. And if I subtract pi by 2 from initial angles, I will be at negative y-axis. So angles like negative pi by 2, if I measure that in clockwise sense, 2 pi minus pi by 2, 4 pi minus pi by 2 will be the angle where you will be on negative y-axis. Now, is there any way I can convert all of these angle with some symbol? Likewise, we used to find the nth term of any sequence. So there we go. Your even multiple of pi by 2, sorry, your even multiple of pi ensure that you will be at positive x-axis. Wherever odd multiple of pi by 2 will lead you on negative x-axis. Similarly, if you add a pi by 2 in even multiple of pi, that means you are at the positive y-axis. Wherever instead of adding, if you subtract pi by 2 from 2 and pi, you will be at negative y-axis. So after all this, let me consider any sine function corresponding to their angles. Say if I am at positive x-axis, their corresponding angles are 0, plus minus 2 pi, plus minus 4 pi, so on and so forth. So can you tell me the value of sine theta corresponding to all of these angles? Yes, the answer will be 0. We all know that sine is a periodic function and its period is 2 pi. That means we will keep getting repeated value after an interval of 2 pi. Similarly, if we are at negative x-axis, or you may call it the angles are odd multiple of pi, that what will be the value of sine corresponding to these angle? Then you would say still the values will be 0. Still the value will be 0. Because we know the value of sine pi is 0, that means 3 pi, 5 pi, and every odd multiple of pi will give you a result equals to 0. Now, if I try to, assimilate the result on x-axis, your x-axis consists even as well as odd multiple of pi by 2. That means which can refer as n pi. So the result corresponding to this n pi will give you a 0 in sine. Will give you a 0 in sine. Now let's have a look on the y-axis. First of all, what positive y-axis will bring us. So if we are on positive y-axis, then definitely we are at 2n pi plus pi by 2. So at these angle, you may put different values of n to get the value of sine function. For example, for n equals to 0, we get sine pi by 2 and it is equals to 1. And once we get 1, and then after a revolving of 2 pi, we again are at the same point and still will get the 1 as a response. So for every 2n pi plus pi by 2, sign will ensure a positive 1. But will it be the same case for negative y-axis? So let us check. Do we already aware with the graph of sine function? For example, if I put the value of n equals to 1, I'll be at 3 pi by 2. And we all know what is the value of sine at 3 pi by 2. It is 1. It is negative 1, excuse me. So if it is a negative 1, then another negative 1, which will I get after a 2 pi length interval. That means this 2n pi minus pi by 2 will ensure that sine will give us only negative 1 value. So on negative y axis, sine, the response of sine will be negative 1. Now, what about the cosine? If cosine is there, then even multiple of pi will give you a positive 1, because we all know the value of cosine at 0, 2 pi, and then we don't need to remember or learn the how will I get the value of cosine or at another even multiple of pi. We always get a 1. Now, if we are at the negative x-axis, then cosine will give you a negative 1. Cosine will give you a negative 1. Similarly, on positive y-axis, cosine will end up will give us a 0 as an output. Now, what if I am at negative y-axis? At negative y-axis, still will get a 0. Still will get a 0. So now, is there any way I can assimilate the result corresponding to y-axis? So we may write y-axis either n pi plus pi by 2. You may also call it n pi minus pi by 2, or 2n pi plus or minus pi by 2 is also acceptable. So corresponding to these angles, cosine will give you 0 as output. So there we have a 0. Now, the way we get the result for sine and cosine, we may also generate the result for tangent, since tangent is the result of ratio of sine and cosine. So if sine even or odd multiple of pi will give you 0, that means 10 will also ensure this legacy, and we end up getting a 0 on either side of x-axis. So there we go, 10 corresponding to angle n pi will always give you value equals to 0. But what if we have on y-axis? As we know, on y-axis we get 0 corresponding to cosine, and cosine will occur in denominator. As far as 10 is concerned, then no value of 10 will be there at 2n pi or 2n pi plus pi by 2, or at 2n pi minus pi by 2. So whenever we have to write a value corresponding to 2n pi plus minus pi by 2 angle, it is something which is not defined. It is something which is not defined. These values are very essential while attempting any question from trigonometric equation. So now what trigonometric equation is? Trigonometric equation is basically a equation which consists one or more trigonometric function in it. For example, say we have root 2 sine theta minus 1 equals to 0. Now let me involve more than one trigonometric function. For example, let it be sine square theta minus 3 sine theta cosine theta plus 2 cosine theta equals to 0, plus 2 cosine square theta equals to 0. If it is the case, then sir, we already have done this thing in trigonometric ratio, because there was also one or more trigonometric function involved. Then what is the difference between a trigonometric ratio and trigonometric equation? See, your trigonometric equation is satisfied with a set of value. Now this set of value may contain finite or as well as infinite number of solutions. So for a trigonometric equation which satisfied with a set of values, it may be finite or infinite in nature. But as far as your trigonometric ratio is concerned, this trigonometric ratio is satisfied for every value of theta. For every value of angle will satisfy your trigonometric ratio. Let me write down a trigonometric identity there. Sine squared theta plus cosine squared theta equals to 1. Whatsoever value of theta you assign there, this will always be valid. So may I conclude that all trigonometric functions, sorry, all trigonometric ratios are trigonometric equation, but we cannot say that all trigonometric equation are trigonometric ratio. So now there was another term, finite and infinite number of solution. How to find number of solution and how we can ensure that we need to find finite or infinite number of solution. Based on the type of solution, we can categorize them as follow. There are three types of solution which are famous in trigonometric equation. One, it is your particular solution. Another one, it is principal. And the third one, it is general solution. Principal solution are those solution which are random in manner. For example, if I ask you to give me the value of theta, for which sine will give you 1 by 2 as a response. And it is given that you need to find the solution in some particular area. Let the area is from 0 to pi. Then whatsoever values of theta does exist will be known as particular solution, because we are searching the solution is in particular range. Let me write down the solution quickly. It is pi by 6 and 5 pi by 6. Now what principal solution will be then? If we are getting the solution in the range of 0 to 2 pi, then your solution will be known as principal solution. Solution beyond this range will not be counted in that specific solutions. Now the third and the very important one, it is general solution. General solution, that means it is not feasible to write each and every solution which we get from any equation. That is the reason we need to generalize their solution. For example, say I have a equation sine theta equals to 0. If someone asks you to write down the solution for this equation, then it is not feasible to write each and every solution. For example, I may write down a couple of solution only, but based on the pattern, I need to get some idea by which I can generalize their solution. Since we already done with sequence and series, then you may take an idea from there. Theta equals to n pi will be the general solution of sine theta equals to 0. But you need to ensure what your n is. Here, n is a integer. So these are the kind of solution which we'll be discussing in detail in the next lecture.